Hello and welcome to this online lecture. My name is Patty Kokish. Thank you for joining. Today we're going to be doing a midterm exam review for Math 136. We're just going to go through a bunch of different types of problems. They're the types of problems that you'll see on your midterm exam review homework, and then hopefully also some of them will help prepare you for your actual exam. So please make sure that you get in touch with your testing center to set up an appointment for making your midterm exam. And I also want to mention that we won't have a session next week because it's going to be spring break. So let's go ahead and start with this right here, which are different procedures that you can do to end up with equivalent equations. So one of the main goals in math is to not change anything, basically just not screw anything up. So one thing that you can do is you can interchange two sides of an equation. So for example, if you have 3 equals x, we could write this as x equals 3 instead. So there's nothing wrong with just interchanging the two sides. You can also simplify the sides of an equation by combining like terms and eliminating parentheses. Okay, so for example here, they combine the plus 2 and the plus 6 to create a plus 8, and they combine the 2x and the x to get a 3x. You can also add or subtract a number from either side as long as you do it to both sides. So if you look at what they've done here, they just added 5 to both sides in this case, which is completely fine. So as long as you do it to both sides, that's fine. You can also do the same thing with multiplying or dividing. So you can multiply or divide both sides of the equation by the same non-zero expression as long as you do it again to both sides. And then when you end up with something like this, you can use the zero product property. So if you have 0 on one side and the other side is factored, what you can do is you can set each factor equal to 0 in order to solve it. That's the zero product property. So let's look at an example here. I've picked some of the more complicated examples because these are the ones that students tend to struggle on. The other ones, hopefully, you can figure out on your own. But let's look at this one here. This is an equation that looks kind of complicated, but when we actually start to solve it, it leads to a linear equation. Oh, I also wanted to mention, if you have any questions while I'm going through stuff, you should see a questions tab on your GoToWebinar control panel. Feel free to type it along with the slide number, so that I can go back and answer any questions that you guys have at the end. There will be plenty of time if you have any questions for me to go ahead and answer those at the end of the lecture. So let's look at this one here. 2 over x minus 1 equals 3 over x plus 3 plus 1 over x plus 3 times x minus 1. Okay, so for this one, what you want to think about is how to get rid of your fractions, because that's probably the part that you don't like. So in order to get rid of fractions, if you multiply by everything that's in a denominator, then that's going to get rid of it. And we have to do it on the left-hand side and the right-hand side. So if we take our left-hand side and we multiply by x minus 1 times x plus 3, that's going to get rid of this fraction, and these fractions. Okay? And if we do that on the left-hand side, we also have to do it on the right. What you'll notice is on the right-hand side, we also put brackets around this because we need to make sure that we distribute it to both things. So if you look on your left-hand side, hopefully you'll see this x minus 1 is going to cancel. Okay, so we're just left with 2 times x plus 3, which if you simplify that is going to be 2x plus 6. And then on this right-hand side, they've done a little more than I wish, but if we look at it, if we take this x plus 3 times x minus 1 and we factor it into this, okay, so we distribute, the x plus 3's are going to go away, so we're left with 3 times x minus 1, which is what's right here. And then if we look at this part, the x plus 3 is going to cancel with this x plus 3, the x minus 1 is going to cancel with this x minus 1, and we're just left with plus 1, okay? And we went ahead and distributed our 2 through on the left-hand side, so we have 2x plus 6 equals 3 times x minus 1 plus 1. So this obviously looks much, much nicer than the original equation. So my suggestion to you is anytime you have an equation that has fractions in it, go ahead and multiply by the denominators, okay? Or you want to multiply by the thing that gets rid of all of the denominators, all right? And then do that to both sides, distribute, and simplify. So now we just have to distribute our 3. Okay, so we have 2x plus 6 equals 3x minus 3 plus 1. And then we want to get all of our x's on one side, all of our numbers on the other side. So it looks like they decided to put the x on the left. So if you subtract 3x from both sides, you get a negative x. And then we subtract 6, and we go ahead and simplify this part, and we get negative 8. So we have negative x equals negative 8. That means that x equals positive 8. So if we multiply or divide both sides by negative 1, we're going to get x equals positive 8. Now, there is no reason that you should miss any of the linear equation type questions or any equation type questions at all on the exam if you know how to solve it, because you can always go back and check your answer. Okay, so what I would highly recommend is that at this point you would go back and you'd put your 8 into your equation. Now, it's not going to be very pretty, but you can do it, okay? So you'd get 2 over 7, and then what you would do is you'd put the 8 on the right-hand side, and then use your calculator to help you. So go ahead and do 3 over 8 plus 3, okay? So you'd get 3 over 11, and then you'd have 1 over 8 plus 3 times 8 minus 1. So let's see, this would be 11 times 7, right? So you'd get 1 over 77. And then if you simplify this, 3 over 11 plus 1 over 77, you should end up with 2/7, okay? And your calculator will do this for you. If you do 3 over 8 plus 1 over 77, hit your enter key, and then use your fraction to decimal key, which if you're not sure where that lives, you could do some Googling, but it normally on most of the scientific calculators, it lives above your PRB button. So you'd hit second PRB in order to get to it, and then it will change, your calculator will change your decimal answer into a fraction for you, which is very, very nice. So please make sure anytime you're solving an equation that you plug this back into the original to make sure that it actually works. Okay, so moving on. Quadratic equations was kind of the next thing that we hit on in this class. So a quadratic equation is just any one that's in the form ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. Because if a were 0, then we wouldn't have a squared term, which would just make it linear. So if we want to solve this here, we have x squared minus 4x equals 0. We want to go ahead and factor. Now this one actually has a common factor that we can take out of both pieces, and that's an x. So if we take an x out, we get x times x minus 4 equals 0. And then we can use that zero product property. So if you have 0 on the right-hand side and you have something factored on the left, you just set each piece equal to 0. So I would set x equal to 0, and I would set x minus 4 equal to 0. And then I have to simplify this one over here a little bit by adding 4. So I get x equals 0 or x equals 4. So our solution set is 0, 4. Now again, you can check these really, really easily. This one's much easier to check. So if we take 0 and we plug it into the original, we have 0 squared, which is 0, minus 4 times 0, which still is 0. 0 minus 0 is 0. So that one works, okay? And then if you take 4 and you plug it in, 4 squared is 16, minus 4 times 4, which is also 16. 16 minus 16 gives you, again, 0. So this 4 works as well. This is a really good idea to check these to make sure that they actually work. Okay, let's look at this one right here. Let's say we have x squared equals 6 minus x. So if you'll notice, this one is not arranged so that 0 is on the right-hand side. So we probably want to start by doing that, getting everything on the same side. So we can add x to both sides and subtract 6. So we end up with x squared plus x minus 6 equals 0. And then this one, you should be able to factor this. So we're looking for something where the product is negative 6 and the sum is positive 1. So that's going to be a positive 3 and a negative 2. So this factors into x plus 3 times x minus 2. And again, we use the zero product property. So we'd get x plus 3 equals 0 or x minus 2 equals 0. And then we just subtract 3 from both sides. So we get x equals negative 3. And we add 2, so we get x equals positive 2. So our solution set is negative 3, 2. Again, we can check this one, and I suggest always using your original in case you made a mistake from your original to the next step. So if you plug negative 3 in, negative 3 squared should give you a positive 9. 6 minus negative 3 is going to become 6 plus 3, which is also positive 9. So you get 9 equals 9, which is a true statement. So negative 3 works. And if you plug 2 in, you have 2 squared, which is 4, and you have 6 minus 2, which is also 4. So you get 4 equals 4, which also works. The only thing that this won't help you with is if you forgot one of the solutions, it's not going to help you find it, but at least what it will do is help you make sure that the solutions that you have are correct. Okay, now it's important that you know the quadratic formula as well. So if we look at something where we have a quadratic equation and we can't factor it, okay, what you can do is you can use the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, what happens if you have b squared minus 4ac, if you get a number that's less than 0, so I get a negative under here, we aren't going to have any real solutions, okay? So we're going to have no real solutions. If you get something that's greater than or equal to 0, though, you will get some kind of real solution. If this is equal to 0, you're going to get one solution. If it's greater than 0, then you're going to get two solutions. And you're going to find them by using the quadratic formula. Okay, so let's look at this example here. We have 2x squared plus 3 equals 2x. We need to get everything so it's on the same side. I would suggest the left-hand side. So we have 2x squared minus 2x plus 3 equals 0. So first thing I would suggest doing actually is going ahead and writing out what your a, b, and c are. So what I would do is I'd write a equals 2, b equals negative 2, c equals 3. So I jot those down on my paper so that I can actually use the quadratic formula. What they've done here is they went ahead and they looked at the discriminant, which is your b squared minus 4ac part. So they took negative 2 squared minus 4 times 2 times 3. So if you do this, you get negative 20. And what you'll notice is that that's less than 0, okay? So that means that when I set up my quadratic formula, I end up with a number that's less than 0 under my square root, which is going to give me no real solution. Okay. Now, the next thing that you guys did in this class, I think, was complex numbers, okay? And it's possible that I'm skipping some topics that you've done. I highly recommend that if you're confused on any one topic, that you go to the Ivy Tech YouTube website and take a look at the other videos that there are, because every week I produced a video on the topics from that week. So if there's a particular topic that you're struggling on, you can go ahead and locate the video there. And if you can't find it, you can always contact me. So if we look at this here, we have a plus bi plus c plus di. What we can do is we can rearrange this so that we put the real parts together, the a plus c, and we put the imaginary parts together. So you can always do this with differences as well. So the easiest way to show you guys this is to look at an example. So let's say we have 3 minus 2i plus 5 minus 4i. What we're going to do is we're going to combine kind of our like terms. So we're going to put the real parts together and the imaginary parts together. So if we do this, we can do the 3 plus the 5, okay, and then we can do the negative 2 plus the negative 4. So what we end up with is 8 minus 6i. So we have the 8, which comes from the 3 and the 5, and then the negative 2i minus the 4i is going to give you a negative 6i. You always want to make sure that you write it with the real part first and then the imaginary part. This is the standard form for an imaginary number. Now over here, we're subtracting, so you just have to make sure that you distribute this negative sign. So when you do that, you're going to end up with 3 minus 5 and negative 2 minus negative 4. So 3 minus 5 is going to give you negative 2. That gives you your real part. Negative 2 minus negative 4i is going to be a positive 2i. And make sure that you leave it like that. Now, one kind of interesting thing about the imaginary unit, hopefully you remember this, is that I squared is negative 1, okay? So complex numbers are always going to be in the form of a plus bi, where a and b are real numbers. The real part is called, that's your a, okay? And then the imaginary part is the bi part. So if we look at this right here, we can FOIL this the same way that we would FOIL anything else. So we do our first two terms, 3 times 5. Then we do our outer terms, so we do 3 times negative 4i. And then we do our inside terms, which are negative 2i and 5. And then we do our last terms, which are negative 2i and negative 4i. So this isn't really too difficult once you master it, but this is something that I see students kind of mess up a lot on the exams. They forget signs, that kind of thing. The most important thing on this is just being really, really careful. Okay, so if we go ahead and simplify this a little bit, 3 times 5, that gives you 15. 3 times negative 4i is going to give you negative 12i. Negative 2i times 5 gives you negative 10i. And then if you look here, negative 2 times negative 4 gives you a positive 8, and then you have I times I, which gives you I squared. Okay, so if we look at this a little further, hopefully you recall I squared is negative 1. You should never have an I squared in your final answer. You should always replace that with a negative 1. So if we look at this, we have 15. We put the negative 12i and the negative 10i together to create negative 22i. And then we've replaced our I squared with a negative 1 here. And then if we simplify this just a little bit further, we'd have 15 minus 8, which is going to give you 7 minus 22i. So that would be your final answer there. And this is a little bit backwards from the problem, but this is exactly how you find the product. But I think you guys are already comfortable with this foiling method, so I would stick with that since you're kind of used to it already. Okay, the next thing that we did was solve some radical equations. So let's say we want to find the real solutions of the equation, the cube root of 3x minus 1 minus 2 equals 0. So if we want to do this, we want to get the cube root by itself, okay, so that we can get rid of it. So if we add 2 to both sides, we're going to get cube root of 3x minus 1 equals a positive 2. And then in order to get rid of a cube root, you cube it. So kind of same idea with square root. If you want to get rid of a square root, you square. If you want to get rid of a cube root, you cube. So if we cube the left-hand side, we also have to cube the right-hand side. So we have cube root of 3x minus 1 cubed equals 2 cubed. So the cube root and the cube are just going to cancel, okay? And you're just left with 3x minus 1. And then 2 cubed is going to be 8. So then we add 1 to both sides. We get 3x equals 9. Divide by 3, we get x equals 3. Now, hopefully you recall, anytime we have an equation, I want you guys to check it. Okay, so if we actually do this, if we plug 3 in, 3 times 3 gives you 9. 9 minus 1 gives you 8. Cube root of 8, if you're not sure of this, you can put it in your calculator, but cube root of 8 is just 2. So we end up with 2 minus 2 equals 0. So that one works. All right, let's say we have something that looks like this. Square root of x plus 1 equals negative x plus 1. So if we square both sides, because we want to get rid of our square root, if we square the left-hand side, we have to square the right-hand side as well. So when we square the left-hand side, it's just going to go away. The square root and the square cancel, so we're just left with x plus 1. And then if we square the right-hand side, I'm not going to go through all the details because hopefully you're really comfortable with squaring things by now. But when you square your negative x, you get x squared. When you do your outer and your inner terms, you get a negative 2x. And when you square your 1, you get 1. And then at this point, we want to get everything so it's on one side. So it looks like we left everything on the right-hand side to begin with. So we subtracted x and subtracted 1 as well. So we got 0 equals x squared minus 3x. And then we rewrote it so that this was on the left-hand side, which makes a little more sense. So you get x squared minus 3x equals 0. And then you can factor that into x times x minus 3, and then use that zero product property. So you get x equals 0 or x minus 3 equals 0, which results in solutions of x equals 0 or x equals 3. Now, I'm not going to do the check for all of these, but like I said, you should have plenty of time on your exam. I would always go back and check it if you do. So I'd plug your 0 into your equation, plug your 3 into your equation, and make sure that those both work. Oh, and they're shown here. So if you look, oh, actually, with this one, it's really important to check. Because you have these radicals, okay, which can result kind of in extraneous solutions. So when we plug 0 in, you get 0 plus 1 equals negative 0 plus 1. We get 1 equals 1, so that one works. But when we plug 3 in, we get square root of 3 plus 1, which is 2, and then we get negative 3 plus 1, which is negative 2. Now 2 is not the same thing as negative 2, so that one is actually extraneous. So our only solution is just x equals 0. So in this case, the checks are really, really important. So when you're solving radical equations, make sure that you check both, because a lot of times when you get two solutions, one of them is actually extraneous. Okay, the next thing that we did was solve some inequalities. So if we have 4x plus 3 is less than 2x minus 1, what we want to do is we want to get everything so it's on one side. So we subtract 3 from both sides, or actually it looks like the way that they did this is they got everything that's attached to an x on one side and then everything else that's attached to a number on the other side. So we subtract 3 from both sides first. So we get 4x is less than 2x minus 4. And then we subtract 2x from both sides. So 4x minus 2x gives you 2x. And then you have less than negative 4 because the 2x's on the right-hand side cancel. And then you just divide both sides by 2. So you solve this pretty much the exact same way that you would solve an equation. You get x is less than negative 2. The thing that you kind of want to note, I'm going to go back one step, x is less than negative 2. I said that you solve this like an equation, which is true, except for when you multiply or divide both sides by a negative number. Okay, so if I were to have a negative 2x in front of here, and then I were to divide both sides by a negative 2, I would have to actually flip the direction of this inequality. Okay, so that's kind of one important thing to keep in mind. So if I'm writing my actual inequality, if you want it in set builder notation, it's going to be x such that x is less than negative 2. And if you want it in interval notation, it's going to be from negative 2 all the way, or sorry, from negative infinity all the way up to negative 2. Make sure if you're not comfortable with interval notation that you review the video where we cover that. And this is just kind of a representation graphically of what this looks like. All right, we can also solve combined inequalities, and this is pretty much the exact same thing, except we just need to do everything to the left-hand side, the right-hand side, and the middle. So in this case, we would probably want to get rid of our fraction first, which we could do by multiplying all sides by 3. So if we multiply the left-hand side by 3, we just get 3. If we multiply the middle by 3, we're just left with 5 minus 2x. And if we multiply the right-hand side by 3, we're just left with 9. So if we go ahead and simplify this by subtracting 5 from each side, we get negative 2 is less than or equal to negative 2x, which is less than or equal to 4. And then we divide all sides by negative 2. And you'll notice the signs were flipped because we divided by a negative number. So we get 1 is greater than or equal to x, which is greater than or equal to negative 2. And then we've sort of rewritten this in a more logical way, which would be to write the smallest number on the left-hand side. So this right here is equivalent to this one right here, negative 2 less than or equal to x less than or equal to 1. So you can write it like this in set builder notation, or you could write it with brackets in interval notation, and it would be from negative 2 to 1, and there are brackets on both sides since both of those numbers are included. And it can be shown on a number line like this. Okay, blending coffees. So the manager of a Starbucks store decides to experiment with a new blend of coffee. She's going to mix some B-grade Colombian coffee that sells for $5 per pound with some A-grade coffee that sells for $10 per pound. She's going to get 100 pounds of the new blend, and then the selling price is to be $7 per pound. And there's going to be no difference in the revenue. She's just selling it a little differently. So for this one, this is kind of a mixture problem. We have to come up with some equations on our own, okay? So if you look at what we've done here, we've kind of drawn a representation of what's going on. We have our B grade, we have our A grade. We have $5 per pound, $10 per pound, and then we have our blend, which puts the two together at $7 per pound. We're going to call X the number of pounds of B grade that we're using. So that means that 100 minus X has to be how much A grade we're using, because when we put them together, we have to get 100 pounds. So if we then factor in the prices, we'd have 5 times our X, which is 5 times the number of B grade pounds, plus 10 times 100 minus X, which is the number of A grade pounds, equals 7 times 100, which is the total number of pounds in our blend. And then if we make this look a little nicer, 5x plus, and then we go ahead and distribute this, we get 1000 minus 10x equals 700. And then we combine like terms, get x's on one side, get the numbers on the other. We get negative 5x equals negative 300, so we get x equals 60. So that means that the manager should blend 60 pounds of the B grade coffee along with 100 minus 60, which gives you 40 pounds of the grade A coffee. Okay, the next thing you had was the distance formula. So if we want to find the distance between 2 points, we're going to use this formula down here. You take your x2 minus your x1 and you square it, and you take your y2 minus your y1 and you square that as well. Add the two together and take square root. So all we have to do is we have to take our -1 minus our 2 and square it, plus our 3 minus our -4 and square it. So we end up with -3 squared plus 7 squared, which gives us square root of 9 plus 49, or square root of 58. Now hopefully you remember how to simplify radicals. I'm not going to go through that right now, but we can take out, or actually no, we can't take out anything. This is not divisible by 4 or 9 or 16, so we can't actually simplify this at all. So this would be your exact answer. And then if they wanted an approximate answer, you would go ahead and put the square root of 58 in your calculator to get 7.62. Okay, now the procedure for finding intercepts. So hopefully you recall how to find intercepts. If you're finding an x-intercept, you let y equal 0. If you're finding a y-intercept, you let x equal 0. So let's look at this example here. We have y equals x squared minus 4. So to find the x-intercepts, we let y equal 0. So I plug 0 in for y. So I have 0 equals x squared minus 4. And then this actually factors into x plus 2 times x minus 2. And then I use that zero product property. So I get x equals -2 from this piece and x equals +2 from this piece. Those are my x-intercepts. And you want to make sure that you write them separately. So this is probably the biggest mistake I see on here, is that students put the -2 and the 2 together in one kind of coordinate, okay? But they should be separate. So when x is -2, y is 0. So you write it like this, -2, 0. And then when x is 2, y is also 0. So you have 2, 0 as an additional point. Now to find the y-intercepts, we just let x equal 0. So I plug 0 in anywhere I see an x in my original equation. And I just get y equals -4. That's going to be our y-intercept. So if I want to write this, I actually write 0, -4. Okay, now symmetry is another thing that we talked about. If something is symmetric with respect to the x-axis, it means that if we replace y with -y, we end up with another point that's on our graph. If we have something that's symmetric with respect to the y-axis, it means that we replace x with -x, and we end up with a point that's on our graph. And then if we have something that's symmetric with respect to the origin, it means that we make both negative. We replace x with -x and y with -y. So if we look at this here, if we want to test this for symmetry, what we would actually do is to find symmetry with respect to the x-axis, we'd replace y with -y, okay? And if we look at this, there's no way that we can make this equivalent to the original, so it's not going to be symmetric with respect to the x-axis. If we want to determine if it's symmetric with respect to y, we take x and we replace it with -x. And if we do this, what's going to happen is -x squared is just going to be x squared. So this actually is the exact same thing as the original. So this is equivalent, so that means that it's symmetric with respect to the y-axis. And then if we wanted to test for the origin, we'd replace y with -y and x with -x. And you would notice that the right-hand side would look the same, but we'd still be left with this -y over here, so that's not going to be equivalent. So this is not symmetric with respect to the origin. Okay, the next thing we did is finding and interpreting slopes of two different points. So if we were given the points -1, 4 and 2, -3, all we're going to do is use our slope formula in order to find the slope. So if we plug these in, we get -3 minus 4 over 2 minus -1, which is going to become 2 plus 1. So we get -7/3 as our slope. So that means that the average rate of change of y with respect to x is -7/3. Now the thing that I like to tell students, it's not done on here, but one really easy thing to do to check this is to go ahead and draw these 2 points. So if you draw yourself just a little coordinate system and put a point at -1, 4, and put a point at 2, -3, what you'll see is that the slope between those two is going to be -7/3. So you can count the rise and the run and make sure that it matches with this. And the other thing that you want to check is make sure that the direction is correct. So if you actually plot those, you're going to get a negative slope, which is going to be going downward, which is exactly what you want. It would be a red flag if you got something where you had an increasing line. Okay, now if you're given some different information, like a slope and a point, you're going to use the point-slope form of line, which is y minus y1 equals m times x minus x1. So you're going to plug in your point, y minus 4, okay, because that's the y-coordinate, equals m, which is -3, that's your slope, times x minus -1. So if we make this look a little nicer, we go ahead and distribute everything. We get y minus 4 equals -3x minus 3. And then we add 4, so we get y equals -3x plus 1. And that's going to be just like this here, where we have 1 as our y-intercept, and then we go up 3 and left 1 in order to actually create our line. We could also go down 3 and right 1. That would also work. Okay, now finding the slope and the y-intercept of this equation here, 3x minus 2y equals 6. We start with the original, and we need to get it to look like this blue line over here. So we need to get y by itself. So if we go ahead and subtract 3x from both sides, then that's going to get this away from our y. So we're left with -2y equals -3x plus 6. And then we want to go ahead and divide both sides by -2. And if we do that, we get y equals 3/2 x minus 3. So that means that our slope is going to be 3/2, okay, or 3/2, and our y-intercept is going to be -3. So if we actually graph it, we have our y-intercept at -3, and then we go up 3 and right 2 to get an additional point on our line. Now, if you recall, a circle is just a set of points that are a fixed distance r, which is your radius, from a fixed point hk. Now, r is the radius, and hk is actually called the center. So we have a standard form for our equation of our circle here, and then we also have a standard form when we have the origin at 0, 0. And then we also have something called our unit circle, which is kind of the easiest one, which has a center at 0, 0 and just a radius of 1. So if we look at this example here, we want to write the standard form of the equation of a circle with a radius of 4 and a center at 2, -4. So we always have h comma k, so we're going to plug those into our equation. So we have x minus 2, because it's x minus h, plus y minus -4, which is our y minus k, so it becomes y plus 4, equals r squared, which is going to be 4 squared, which gives us 16. So this is in standard form because it's factored with your x and your y, and that's how you'd like to leave it if you want to leave it in standard form. Okay, now we have a definition of a function here. So x and y are going to be two non-empty sets. So a function from x into y is just a relation that associates each element of x with exactly one element of y. So if we take a look at these examples, we want to determine if it's a function. This one is not a function because if you look, we have two of the same x's listed, 2 and 2, and they correspond with different y's, 3 and -1. So this one is not going to be a function. If we look at this one though, we have all different x's, -2, 4, 3, and 2. So that one is a function. The x coordinates are going to be your domain, and the y coordinates are going to be your range. And then if we look down here, this one is also not a function because of the 4's. So if we look, we have 4, 3, and 4, -3. So that means that we have the same x corresponding with different y's, so that is not going to be a function. Now you can have repeating y values, but you cannot have repeating x values that correspond with different y's. Okay, now if we want to find the domain, there are a couple things to keep in mind. So with domains, we run into two kind of main issues. One is that our denominator cannot be 0, and then the other one is that square roots have to be greater than or equal to 0. So if we take a look at this, we have a denominator, so we need to find the values that make the denominator 0 so that we can exclude them. So if we go ahead and we factor our denominator, we get x minus 3 times x plus 1 equals 0. So we would get x equals 3 and x equals negative 1 being the two kind of points that cause issues. So our domain is going to be x such that x is not equal to 3 and x is not equal to negative 1. Now for part B, we don't have any issues here because we don't have a denominator and we don't have a root. So this is going to be the set of all real numbers. Now this one, we do have a root. It's an even root, okay, which are the ones that we need to be careful with. So what we need to do is we need to set whatever is under our root, which is 3 minus 2x, we need to set it greater than or equal to 0. And if we go ahead and do this, if we solve this, you're going to get either from negative infinity to 3 halves inclusive, so we have a bracket, or you can write it like this, x such that x is less than or equal to 3 halves. Okay. Now I'm going to skip going through these equations because I think these are kind of logical and I want to go right to the examples. Okay, so if you have a function f of x equals 2x squared plus 3 and you have g of x equals 4x cubed plus 1, if you want to find f plus g of x, all you have to do is just add the two equations together and then probably rewrite it in descending order. So you had the 4x cubed first and then the 2x squared, and then you went ahead and combined the 3 plus the 1 to get a positive 4 there. Now if you want to subtract, you need to make sure that you put parentheses around the second function. So we have f of x, which is 2x squared plus 3, minus g of x, which is 4x cubed plus 1. So if you go ahead and distribute that, you're going to get a negative 4x cubed, a positive 2x squared, and then positive 3 minus 1 is going to give you a positive 2. Now if you multiply, you're going to have 2x squared plus 3 times 4x cubed plus 1. You're going to go ahead and FOIL that, okay? And you're going to get 8x to the 5th. That's your first term. Your outside term is going to give you 2x squared. Your inside term is going to give you 12x cubed. And then your last term is going to give you a positive 3. And this one, if you're going to divide, you just take your f of x, which comes first in your numerator, 2x squared plus 3, divided by 4x cubed plus 1. Now if you could factor both of these and simplify, then you would go ahead and do that, but at this point there's nothing to do to it. Okay, vertical line test is next. So a vertical line test is basically just taking, I always suggest like a pen or a pencil, and you make it vertical, okay, so it's going to be up and down, and then you move it across your graph than one point at any time, then it's not going to be a function. So if we look at this, for example, we have this parabola here. If we take our vertical line, all right, so I'm going to take my vertical line, and I'm going to move it across. I don't run into any issues because everywhere that I move it, it only hits my graph once. So that's going to be a function. And then with this one right here, y equals x cubed, I take my vertical line and I move it across. Again, I don't run into any issues, so this one is also a function. But if we look at something like this, if I take a vertical line and I move it, anywhere that I put it, I'm hitting my graph actually 2 times. So that means that this one is not a function. And then same thing with the circle. If I take my vertical line and I move it across my circle, I hit my graph in 2 points for a lot of the time. So this one is also not a function. Okay, now we can also obtain various pieces of information from a graph. So if we want to know what f of 0 is, that means that we're going to go over to x equals 0, and we're going to look up, and we're going to get the y value. And at 0, the y value is actually 4, okay? And then for some reason, I forgot these solutions here. F of 3 halves is going to just be 0, and f of 3 pi is going to be negative 4. Now, if I want to find the domain, that means that I list all of the x values. So my smallest x value that I have is 0. Okay, so I'm going to have a bracket there. And my largest x value is 4 pi. Or I can write it in set builder notation like this. The range is going to be the y values. So I look from the bottom to the top. The smallest y value that I hit is negative 4. And the largest y value that I hit is positive 4. So our range is from negative 4 to 4, and we have brackets because those numbers are actually included. If I want to list the intercepts, I'm going to have an intercept at 0, 4, pi over 2, 0, 3 pi over 2, 0, 5 pi over 2, 0, and 7 pi over 2, 0. Now, all of these four right here, the last four, those are all x-intercepts, and this first one is a y-intercept. Now, if we want to know how often does the line y equals 2 intersect the graph, we could just draw that line and count the number of places that it hits. And if you look, it hits it 1, 2, 3, 4 different times. And then we want to know for what values of x does f of x equal -4. So if we look at this, we see that at these two red dots right here, that's where y is -4. So it's going to be at x equals pi and x equals 3 pi. And then for what values of x is f of x greater than 0? So if we look at this, we're looking at the points where we have something that's above our x-axis. So that would start from here to here. Okay, so from 0 to pi over 2. And then from 3 pi over 2 all the way to 5 pi over 2, we're also above our x-axis. And then again from 7 pi over 2 to 4 pi. Now you'll notice at any of the x-intercepts, we have parentheses, not brackets, because we have strictly greater than, not greater than or equal to. So that means that we do not want to include those numbers. Okay, I am going to skip the even and odd because I want to make sure that I'm able to answer any questions that you guys have. But as long as you understand the x-axis, the y-axis, and the origin symmetry, you should understand even and odd as well. But make sure that you go back and review that chapter if you're a little bit fuzzy on it. Okay, if we have this piecewise function here, that means that the function f is defined differently based on the values for x. So, for example, if x is between -1 and 1, then we're going to use this first function. If x is equal to 1, then we're going to use the second function. And if x is greater than 1, then we're going to use this third function. So if we want to find f of 0, that means that we take 0 and we plug it in for x. And we have to figure out which piece we need to use. Now 0 is between -1 and 1, so that means we're going to use the first piece. So if we take 0 and we plug it in, we have -0 plus 1, which just gives you 1. If we want to find f of 1, that means we're going to use the second piece because we're supposed to use it when x is 1. So we just get 2 out. And then if we want to find f of 2, we're going to use this last piece because 2 is greater than 1. So we have 2 squared, which gives you 4. Now the domain is going to be all x values. The smallest x value that we allow is -1, but the largest is going to be infinity because this is the definition for any numbers where x is greater than 1. So if we look at the actual graph, we have a line for this portion from -1 to 1, and then at 1 we have a value of 2, and then from there on out we have a parabola. And then the range is going to be all the y values. So if you look at the smallest y value you have, it's going to be 0, not included, up to infinity. Now, I'm going to just go through these functions that we have. A constant function is just a horizontal line that goes through whatever number you're talking about. So for example, if I had f of x equals 3, that would just be the equation f of x equals 3, or we could say y equals 3, and it would just go right through my y-axis at this point. Identity function looks like this. It's just a line that creates basically a 45-degree angle with your x-axis and your y-axis here. The square function is a parabola, okay? Cube function looks kind of like a sideways elongated S, okay? Square root function is like half of a sideways parabola. Cube root function actually looks very, very similar, except it has a piece in the third quadrant as well. Reciprocal function has kind of this little U shape over here and a U shape also in the third quadrant. Absolute value function is easy to remember because it's shaped like a V and you have a V in the name. So the reason that I went through these is because you need to be familiar with these in order to do transformations. So one thing I would definitely do before you take your exam, if you're not familiar with these, is put these on flashcards. Put one on one side, put the equation on the other, excuse me, and then go ahead and go through them, carry them around with you until you know them. So what we can do is we can actually do transformations. So if we have f of x equals x squared, and we want to obtain the graph of x squared minus 4, all we would do is we would take our original graph, which is this black graph right here, and then we'd shift it down 4. So if you notice over here, what we did is we picked some points and figured out what our values are. This is a perfectly fine way to do it. It's going to be much, much faster if you know the actual transformations. So if you know the fact that when we add or subtract a number after or outside of our equation, it's going to move it either up or down, then that's going to save you a lot of time because you should know the shape of x squared. It's just going to be a parabola. And then you could take that and just shift it down 4 and you get your new picture right there. But if you're not sure how to do this, then picking points is a really, really great way to solve it. Now, here are kind of the rules for shifting up, down, left, right, but I just want to look at this example here. If we have g of x equals x minus 2 squared, this negative 2 is now kind of inside of my function. When I have something that's inside of my function, I'm either going to shift it right or left. Now, if you have a negative sign, it actually shifts it right. So what we're going to do is we're going to take our black graph, which is our f of x equals x squared, and we're going to shift it to the right 2 units. And we end up with this blue graph right here. Now we can also shift to the left. So if we have x plus 4 squared, again, this is inside of my function, so it's either going to move it left or right. And since I have a plus 4, it's actually going to move it to the left 4. So I'm going to take my black graph and shift it over to the left by 4 units. And I end up with the blue one that's right here. Now I can do all of these at once, so I can do vertical and horizontal shifts together. And if you look, this minus 5 is outside, so that means it's going to move it down 5. And then this plus 3 is inside, so that means it's going to move it to the left 3. So if you look, the x was replaced with x plus 3, so I shifted it left 3 units. And then I also subtracted 5, so that means that I should shift my graph down 5 units. So I took my original x squared graph, which looked like our parabola, our u, and I shifted it left 3 and down 5 to end up with this new graph. And again, if you're not sure on these, you can always plug in some points to kind of double check, but if you actually know the transformations, it's going to be much, much better. We can also do things called vertical stretches, okay? So if we have g of x equals 2 times the absolute value of x, it means that we take our original graph, which is this black graph here, y equals absolute value of x, and we kind of take it vertically and we stretch it out, okay? So we multiply all of our y values by 2, and we end up with a slightly more narrow graph from the original. Again, you can plug in points to see what this looks like. Now we can also do a vertical compression, which would mean that instead of making it skinnier and taller, we kind of make it more flat and wide. Okay, so if we look at this blue graph here, this is g of x equals 1/2 times the absolute value of x. Because we have a fraction that's between 0 and 1, it's vertically compressed our graph instead of stretching it. Now we can also do reflections. So if you want to reflect around the x-axis, if we take y and make it into a negative number, then what we're doing is we're reflecting around our x-axis. And these, I always suggest to students to pick a couple of points to make sure that you did the correct reflection, because it's really, really easy to screw them up. Okay, so for example, if you plug 1 in for x, you'd have negative 1 squared. You'd need to follow order of operations, so you do the 1 squared first, and then you'd stick the negative sign in front, so you'd get negative 1. So that would be this point right here. And that should kind of automatically tell you, oh, yep, I did this right. I should have flipped around the x-axis, and that's what I did. Okay, and then if you ended up with a graph that didn't look like that, then that would mean that you probably did your transformation incorrectly. Now, if you take x and you replace it with a negative x, that means you're going to be reflecting around, this should say y-axis, not x-axis. So we would take our black graph right here, which is y equals square root of x. And since we took x and replaced it with a negative x, we're flipping around our y-axis. So we end up with this blue graph right here. And if we look at this example right here, this combines many of the procedures that we had. So if we have f of x equals square root of 1 minus x plus 2, if we take a look at this, the first step is to go ahead and graph the original, which is just going to be square root of x. And then we replace x with an x plus 1. So that means that we take our graph and we shift it to the left by 1. And then what happens is we replace x with the negative x, which means that we should take our new graph and flip it around the y-axis. So now it's oriented this way. And then finally, we have this plus 2 that's added, so that means that we need to shift it up 2. So if we do that, we take our graph from step 3 and scoot it up by 2, and we end up with this blue graph here. Again, pick a couple points, make sure that your graph actually matches before you select your answer in MyMathLab. Okay, now if you want to graph a linear function, these should be pretty easy, okay? And we did do a couple of examples where it's kind of nested within a different example. But if you're given something that's in slope-intercept form, what you want to do is you want to plot your intercept first, which is going to be at 0, 1. So you actually put your dot there. And then from there, you use your slope, which is going to be 2/3. So that means that I should go up 2, and I should go right 3, and I should pick another point and put it right there, okay? And then I just connect my lines. Now, you can also go down 2 and left 3, but you want to make sure that when you do it, that you've created something where the slope matches what it should match. So if you look at this, if we actually connect these dots, we end up with definitely something that has a positive slope. And if you look here, we also have a positive slope, so that's good news. If we had created something where the slopes looked negative, it would mean that we did something incorrectly. Now, average rate of change is just kind of an alternate word for slope, all right? So it's important that you understand how to use this, okay? But you want to also be able to recognize that if you see average rate of change, it's just your slope, delta y over delta x. So change in y's over change in x. All right, now if we look at this example here, we have f of x equals 2x squared minus 3x plus 2. We first want to know if it opens up or down. So if you recall, it has you locate the vertex and the axis of symmetry first and then answer if it opens up or down. So the vertex, hopefully you remember this, is the opposite of b over 2a. And then once you have that, all you have to do is plug it back in to get the y coordinate. And make sure when you're studying for your exam that you're looking at the formula sheet that's actually going to be given to you on your exam, which lives, I believe, in the session 7 folder, okay? So make sure you print that and use it since it is provided to you guys. So if we take the opposite of b over 2a, that means we'd take the opposite of negative 3 over 2 times 2, which would give us 3/4. And then we would have to take our 3/4 and actually plug it in, okay? Now I'm gonna leave that for you guys to do. So you'd take 3/4, you'd square it, multiply by 2, subtract 3 times 3/4, and then add 2. And if you simplify this, and you can use your calculator to do this, you'll get 7/8. So your vertex is at 3/4, 7/8. The axis of symmetry is always x equals the x coordinate of your vertex. So it's x equals 3/4. And then this one is going to open up because you have a number that's greater than 0 here. If we had a negative number, then it would mean that it would open down. Now here are just kind of some examples visually of various parabolas. Axis of symmetry is always x equals opposite of b over 2a. The vertex is going to be opposite of b over 2a, and then you plug that in order to get your y coordinate. You can see that sometimes we have 2 x-intercepts, sometimes we have only 1 x-intercept, and occasionally we can have no x-intercepts at all, which would happen if you're situated above the x-axis and it opens up, or below the x-axis and it's opening downward. So if we look at this example here, we have f of x equals 2x squared minus 3x plus 2. We know that our vertex is 3/4, 7/8, and the axis of symmetry is 3/4. So if we look at this on our actual graph, we have something like this, and then we also know that it's opening upward. We could find the y-intercept by just plugging 0 in for x, which is going to make all of this stuff go away, so you just get 2. And then because of symmetry, we get an additional point to the right of our axis, and we can just connect these. And you'll see we do not have any y-intercepts, or sorry, we have one y-intercept at 0, 2, but we do not have any x-intercepts. So if we were asked to find the x-intercept, we would just say that we have none at all. Now, if we want to determine the domain and the range, domain is going to be all x values from negative infinity to infinity. So if you think about that, you have values all the way across our number line, all the way from negative infinity up to infinity. And then the range is going to be the y values. And if you look, the smallest y value that we have is going to be at 7/8, and it's included, so we have a bracket there. And then the largest y value is going to be up at infinity. Increasing is going to be kind of this green portion here where we have something that's going upwards, and that's going to happen all the way from 3/4 all the way to infinity, and we're talking about x values here. And then decreasing is this red portion, and that starts over at negative infinity and continues all the way until we get to 3/4. Now, one kind of important thing is that when you're giving increasing and decreasing intervals, you put parentheses, not brackets, because when we're talking about increasing and decreasing, it never includes actual points. It should always be parentheses, not brackets. So if we look at this example here, we have f of x equals 2x squared plus 4x minus 1. If we find the vertex, it's going to be the opposite of b, so opposite of 4 over 2 times 2, which gives you -1. And then you plug that back in to find k, so we take -1 and we plug it in, and we get -3. So that means that our vertex is at -1, -3. So we plotted that right here. Axis of symmetry is going to be x equals -1. And then since a is greater than 0, because a is 2 right here, it's going to open up. Now we can find our y-intercept by plugging 0 in for x. It's going to be this number right here. So we have a y-intercept at -1, and then we use symmetry to find an additional point right on this side. And we connect these to get this parabola right here. Now, if you actually look, we can also find our x-intercepts. They look to be not very nice numbers, but we can still locate them by plugging 0 in. Okay, so we have 0 equals 2x squared plus 4x minus 1. And then we can use the quadratic formula to actually solve that. Now, if you had something like this and you could factor it, then you would go ahead and do that. But in this case, we cannot actually do that, so we have to use quadratic, all right? And what you end up with is -2 plus or minus square root of 6 over 2, which if you plug that into your calculator is about at 0.22 and -2.22. Now, again, we could find domain, all real numbers. Range is going to be from -3 all the way up to infinity. Increasing is going to be this green part right here, which happens from -1 all the way to infinity, and decreasing happens from negative infinity all the way up to -1. Now I'm going to skip this example here because we're running out of time. I want to make sure that I have time to answer your questions. And I want to do one last example, solving an inequality. Okay, so if we have a quadratic inequality, there are a couple of different ways you can solve it, but I think that the easiest way is to do the steps that I've outlined here. Okay, and I did several examples last session on this particular topic. So if we have something like this where you have x squared less than or equal to x plus 6, we first want to write the inequality so that the left side has everything on it and 0 is on the right hand side. So for step 1, we would just rewrite this so we have x squared minus x minus 6 is less than or equal to 0. Step 2 is to find any real zeros, so we actually factor this, and it's going to factor into x minus 3 times x plus 2. So the real zeros are going to be x equals 3 and x equals -2. And then what you do is you create a number line, okay? You're going to put points 3 and -2 on the actual number line. And then you're going to write out the intervals. So this first interval is going to go from negative infinity up to -2. And then we're going to have an interval from -2 to 3. And then we're going to have one last interval from 3 to infinity. And then what you do is you pick a number in each of the intervals. So you pick -3, and then you plug it in, okay? And you always want to plug it in to the equation from step 2, okay? And if you plug this in, you get 6 out, which is a positive number. Now in this interval, you can pick 0 because 0 is between -2 and 3. And if you plug that in, you're going to get -6 out, which is a negative number. And then over here, I picked 4. I'm going to plug 4 in here. and I'm going to get 6 out, which is a positive number. Now, if you look at what I actually want, I want less than or equal to 0, so that means that I want the -1. So I'm looking for anything where I have a negative sign here, which is the interval from -2 to